Alrighty guys, so we're going to add to our notebook today, actually the last topic that we're going to talk about in our introduction to geometry. So test coming up soon. So in our table of contents, I goofed up and forgot a line. So we're going to add another line. So if you want to put IG7, so Intro to Geometry, our 7th topic, we're going to be talking about area, perimeter, and circumference. And we will be doing that on page 14 only. It's really nice to end with a one page. That's because we're going to put that divider for our next chapter around the next page, okay? So if you can leave 15 blank, that would be ideal. All right, so if I turn to page 14, you'll notice that I already have some stuff written down. So I have the page, I have our title. I'm going to fill some things in with you here. But once I get to our examples, you might want to pause to write these questions down and then do the examples with me. I just wanted to save us some time in the video. Okay, so when it comes to area, perimeter, and circumference, we're going to talk about some basic shapes today that you really probably should already know how to find the area, perimeter, and circumference of. So hopefully this is a little bit of a review, but we'll actually talk about area in more depth later. So these should be very basic problems, very basic formulas that we're going to use. So I'm going to start with our formula review. So when it comes to area, when I'm finding the area of a thing, I'm figuring out how much space it takes up. Okay, so when I'm finding the area of a piece of paper, how much paper there is. Versus when I'm finding circumference, I'm finding out how much around. So kind of like a fence. A fence is a really good example of circumference because I just want to know how much fencing I need. It's not about what's inside the fencing, okay? And circumference is really just the circular word for perimeter. So circumference is how much around the circle. So I don't know if any of you know about horses, but some horses will have a circular pen that's also made with fencing. And so how much fencing you need in your circular pen would also be an example of perimeter or circumference for a circle. So like I said, we're going to talk about 4 shapes. The first shape that I want to talk about is a square. And so if I draw a cute little picture of a square, we hopefully remember that all the sides are the same, so I can mark them all congruent. Also, all of the angles are 90, so I could put little squares in each of the corners, but in geometry, you can actually just put it in one, and it's kind of understood then the rest of them are, if it's a square. And we'll get more into that later as well, but for now, one right angle is fine. So if I were to call the side of a square S, and I don't need to put it on all of them because the tick marks tell me that they're all the same, then I can find the area of a square by doing side squared. So side times side. Area is always a unit of measure that is squared. And if I want to do the perimeter, perimeter is how much around, and so we just add up all the sides. So if I do S plus S plus S plus S, so 1S plus 1S plus 1S plus 1S, that's just really 4 S's, so 4 times S to find our square, area, and perimeter. Super, super simple, hopefully. Okay, another shape that I want to talk about, kind of like a square, is a rectangle. A rectangle looks sort of similar to a square, except for maybe it's longer or taller. And so when we have a rectangle, we have that 2 sides are the same, and then the other 2 sides are the same as each other, but not the same as the first. Okay, so we have 2 pairs of congruent opposite sides. Also, all the angles are 90, so we can put a little box in one of the corners. And maybe you remember finding the area of a rectangle and calling it length times width. But it's not super descriptive. Some people look at this as length, And some people look at this as width. And so a better word to use is base and height. And we're going to get more into that too when we talk about area, but a height is specific. A height has to be perpendicular. So here's our height, here's our base. I'm going to go with H and B to describe our two sides here, okay? I mean, really you can use whatever letters you want, but they do have to be different because they're different side lengths. I just like H and B because height and base, and there's a reason for heights. So yeah. If I want to find the area of a rectangle, I find by doing kind of like the area of a square. I multiply a side times a side. However, in this case, since they're not the same, I can't put side squared. I'm just going to do base times height. That's your area. And again, it is going to be units squared because I'm multiplying two things. And if I'm multiplying two things, we get that little squared symbol. So like if it's in centimeters times centimeters is centimeters squared. Versus perimeter, I'm not multiplying double things. So perimeter is always just units, so centimeters. Now when I'm doing perimeter here, we want to add up all of our sides. And so if I do base plus height, or maybe base plus height, I have two bases and two heights. And so the simplified formula is 2b plus 2h to find the perimeter. Okay, so we have our cute little formulas here for finding area and perimeter of a rectangle. Another shape that I want to talk about, pretty simple shape, triangle. We're going to talk lots about triangles in this class. They're so fun. So triangle can sometimes be a little bit tricky when we want to find the area or the perimeter. Perimeter is not so bad, but with a triangle, you might have a dashed line drawn somewhere inside your triangle or maybe even somewhere outside your triangle with a perpendicular mark on it, so a 90-degree mark on it. And that's because when I want to find the area of a triangle, I have to have that perpendicular height. Okay, so we need that height, and then whatever side it is perpendicular to is your base. And then just in terms of finding the perimeter, I'm going to label our other two sides, one as an A side and one as a C side. Okay, so first of all, if I want to find the area of a triangle, maybe you remember the formula for that. Some people like to say half base times height. I usually just write it as base times height over 2. Because you can choose. You can divide the base by 2 or you can divide the height by 2. Either one, but not both. And then for our perimeter, there's kind of no shortcut here because it could be that all the sides of our triangle are different. It could be that all the sides of the triangle are the same, but that's kind of a special case. And so we don't want to over assume things here. So to find the perimeter, we're just going to add all sides. So A plus B plus C. Now again, there could be cases where we have some triangles where all of the sides are the same, or maybe some of the sides are the same, and we'll definitely talk about those. But in general, we just want to add all sides. And not the height, because that's not really a side, so we don't include that. And last but not least, I want to talk about a circle. There are lots of other shapes that we will do the area of later, but for now we just want our simple base shapes. And so a circle is sometimes drawn with a line in it, sometimes just a half line, sometimes a full line, but that line is important. And when it's drawn like this from center to edge, it's called a radius. When it's drawn from edge to edge through the center, it's a diameter. And so a radius is always half the diameter. I think these are things that we know. So if I want to find the area of a circle, now these are the ones that always involve pi. And I remember too, as a student, being confused who is who, because there are two pi formulas and like which one's area, which one's circumference. So area is pi r squared. Circumference is 2 pi r or d pi, where d is the diameter, either one. And so the way that I eventually realized I could tell the difference is because area is always squared, my units. So like if it's centimeters or inches or feet, when I'm finding the area, I say feet squared, inches squared, miles squared, Marissa's squared, oh, Missouri squared. So this is squared. That formula, pi r squared, has to be area then because it has the squared in it. The other one then is circumference, okay? So maybe that's a way to remember it. Hopefully that's kind of helpful to you. And then we can do 2 pi r or d pi if I know the diameter to get our circumference, okay? So those are really the formulas that we need here. And so now is maybe where you want to take a pause on this video and copy down these 3 questions. I'm going to take a quick pause too, just so you don't miss anything. Okay, let's do these 3 examples together. So number 1, what is the perimeter and area of a rectangle with a base of 3 and a height of 7? Now, when they don't specify the units, I always just put units squared or units for perimeter. Okay, so let's say we first want to find the perimeter. The perimeter of a rectangle, our formula is right here, so we'd have 2b plus 2h. They tell me that my base is 3, so in place of b, I can put 3. In place of h, I can put 7. We're going to multiply, then add, and so this is going to turn into 6 plus 14 for 20 units of whatever, because they didn't tell me if these are feet, miles, whales, I don't know. Then we want to find our area. So area of a rectangle is base times height. So 3 times 7, base times height. So my area here is 21 units squared. Easy, easy. Okay, next one, example 2. What is the circumference and area of a circle with a radius of 9? Okay, so if we're going to find circumference of a circle, we got pi r squared. Luckily, they gave me r. Now, if they did not, if they told me the diameter was 10, I'd have to take half first, 5, and then plug it in. Oh my gosh, I picked area. Oh my gosh, I'm just realizing this. I'm so dumb. Circumference, 2 pi r. Bro, it's been a morning. Circumference, 2 pi r. They gave me r, so that's the one I'm going to want to use. If they gave me diameter, maybe I'd use the other one. So if they said the diameter is 10, I could just put 10 pi. But they gave me the radius, so I'm going to use 2 pi r. So we got 2 times pi times 9. So I like to do as much math as I can without a calculator. I can do 2 times 9, that's 18. And then pi is still chilling there at the end because I haven't multiplied it yet. And so here's where we can get a little bit confusing. Oh, centimeters. If we want the exact answer, we have it, 18 pi. That is exact because I can't really multiply by pi because I'll never be able to write it all out because pi never ends. If I want an approximate answer, then I can multiply by pi. And if you go to your calculator, if I can get to my calculator, you actually, if you're on an iPhone too, and I know on Androids as well, I just don't know exactly where, there is a pi button, which is better to use than 3.14. So I would do 18 times pi. That's pi. So I don't have my answer yet. I hit equals, and there I have it. So your approximate answer would be 56.55 if we're going to choose to round to the hundredths place. Okay, centimeters. Versus area, which I can't believe I goofed that up at the start. Well, we all make mistakes. At least we caught it. If I want to find the area of a circle, we want to do pi r squared. And so again, they told me the R was 9, so I'm good to go. But if they told me the diameter was 10, I'd have to take half first to get the radius, so 5, and then plug it in. But I have it, so I can just plug it in right now. So we're 9 squared. I'm going to do all the math that I can without a calculator. So 9 squared is easy. That's 81 pi, which means that your exact answer is 81 pi centimeters squared. The approximate one would be where I multiply by pi. So if I go to my calculator again, I type in 81 times pi. So 254.47 if we round to the hundredths. So it just depends on whether or not we want to exact or approximate. It's very important to read what the question would like. I didn't specify in this example because I wanted to talk about both. But if you notice later in your Google form assignment that it says approximate, we're going to multiply by pi. If it says exact, we're going to leave pi. And if you don't have a pi button on your calculator, or on your computer rather, just put pi for pi, not PIE. That's a different kind of thought. Okay, last but not least, number 3. What is the perimeter and area of an equilateral triangle with a side length of 4 inches and a height of 5 inches? So this is one of those special triangles. Maybe we remember that equilateral means that all sides are the same. So that's kind of nice because if I want to find the perimeter, I can do 4 plus 4 plus 4, but I can also just do 4 times 3 since all the sides are the same. But 4 plus 4 plus 4, because that's what all the sides are. The 5 is the height. It's inside of it. It's not part of the outside of the triangle. And so our perimeter here is 12 inches. Our area formula is base times height over 2, or half base times height. And so the base of the triangle is really any side because they're all the same. So 4 times the height, which is 5 over 2. So here's where I like to write it as this big fraction like that because then I can pick and choose who I want to divide the 2 by. I don't want to divide the 2 into the 5 because it doesn't go. So 2 into 4 is 2, and 2 times 5 is 10 inches squared for our area. Hopefully easy. Try your Google form. Let me know if you have questions.